Thank you, Martia, for the introduction. I'm going to get right into it. Systems programming, lessons from building a networking stack for microcontrollers. I'm Patricio Whittingslow. I'm the creator of lneto, which is the networking stack that runs on these constrained places with around 20 kilobytes of RAM. And I'm a TinyGo maintainer, core maintainer, I'd say. I teach Go at a university course, embedded systems with biomedicine applications, and I've also taken consulting up recently. All right, so this is the agenda for today. The overarching question I'll try to answer is how Go can be used as a systems programming language when so many people say otherwise. So let's circle back to a simpler time. Let me paint a picture. It's mid-pandemic and I'm huddled over my desk, hooking up wires, trying to connect via HTTP to an Arduino. I've limited memory, 32 kilobytes of RAM, and I'm struggling to fit my CSS classes into the program. I've decided to use the Arduino IDE for the last time.
There is no slide anymore.
Oh, yeah. C++ you later. No, that's on purpose.
Is that on purpose?
Oh, yes. It's all part of the suspense. So, I desperately search on my browser, Go for Arduino. TinyGo. It seems a little too good to be true. So, and it was at the time. The LLVM compiler, which TinyGo uses, had serious issues when targeting AVR technologies. By chance, I had found TinyGo at the dawn of a golden age. Soon after trying to put it to work for the first time and running into issues, these issues were to be fixed by the LLVM team. And I'd host my, this one should have a video, but, but I think that's my fault because Google Sheet, snap. It's a screenshot they're saying here. No, I can assure you it's not a screenshot. Okay, you're going to have to believe me that there's a video of a Arduino hooking up via HTTP, and we're getting a LED light to blink. So yeah, let's hear it for the Arduino. All right, let me actually get the presenter view back on. And soon after we got that Arduino to blink, and the CSS was terrible. Just imagine terrible CSS. So that was the first attempt at a networking stack I did 4.5 years ago. That's Ether Switch. The second attempt was Seeks. Featured in the book, gained a lot of users, put kind of TinyGo networking at a low level in the limelight, as to say. And the next generation stack, lneto. That's the one we're working on today. And rest assured, lneto is likely definitive. But first, let me show you lneto in action. And let's hope that the gods of the live coding demos accompany us. So I've already loaded the program onto this CYW43439. Since the FOSDEM network is kind of spotty, I'm on my hotspot. Yes, it's on. My hotspot is on. I'm going to go ahead and plug it in. All right. And so I got here a website, and you can't really see it. I'm sorry, I can't get it to work from my laptop. But I'm going to press this button and really hope that... Oh, there you go. The LED is turning on. All right, you get in that camera, guy, person. And it stopped turning on. No, it's still turning on. So success. Can you can all see it, right? Can I get a yes from the audience? Yes. All right, yes. All right, feeling good. So that's doing DHCP, and then hosting an HTTP server, which you see on my phone screen, not on my laptop screen. So today there's no other way to run a fully fledged networking stack on a microcontroller other than with lneto. So I think it'd be interesting to take a look at how we got to here. Let's take a look at Ether switch's design. So Ether switch implemented these protocols from Ethernet up to HTTP. And this was the first interface I came up with that drove the core idea of the networking stack. Now, any reasonable person would look at that and say, that seems reasonable enough. That's because the reasonable person didn't audit the code. They don't know how I'm using this. You see, a TCP connection would load the entire packet into memory and enter a loop that would call an update function that returned a new update function that was to be called over and over until the packet was completed coded, and the response also encoded. And so you might notice something like to emit data, you needed to receive a packet. To illustrate, if you for some reason needed to send out 2 packets after receiving a single packet, you wouldn't. 1 packet in, 1 packet out. Them's the rules. And this barely worked for an HTTP server. An HTTP client, on the other hand, was out of the design scope entirely. Now, this design was not by accident. Turns out this shallow function calling would save on stack memory, which was very limited on the Arduino Uno at that time. Also, the one-in, one-out decision was on purpose. It effectively made the TCP stack stateless. So a lot of simplicity gains right there. I didn't have to keep track of ACK or seek numbers. And the cost? 100% pedigree unmaintainable code. It may be the lightest on-memory HTTP server in the world, but we don't speak of Etherswitch anymore. All because I wanted to fit in those CSS styles. Can you believe it? But it did get some more CSS styles than the Arduino library let me in on, so some wins. Next up, Seeks. Or sex, depending on your prudishness. It supported NTP, DNS, IPv6. Got something going on for it, and more support. And with Seeks came improvement. The use of a singular is no accident. Behold, my greatest failure to the Go community. I had spent another year and a half on a networking stack, and all I could show for it was that I could now send a packet whenever I wanted. I didn't have to wait for a packet. And I can send 2 packets now, not just 1. And in spite of its shortcomings, Seeks brought with it something new. It became an overnight success in the embedded Go community. Since it was the only networking stack that enabled internet access on the Raspberry Pi Pico W, people started using it, and it's even covered in the book, Home Automation in Go. Seeing that now people depended on it and how Seeks was quite hard to maintain, I set out to design a new networking stack. So in comes lneto. lneto now has IGMP, has everything Ether switch and Seeks has, plus ICMP, IGMP, and RMII. And we can now and now this is the interface lneto uses. As you can tell, it's very it's based off of Go primitive types. Very simple, very easy to implement a stack or a node in lneto, and it's very maintainable. And this right here, this I believe is the forever stack. lneto was here to stay. It's a maintainer's dream come true. lneto gives me peace of mind that we'll be able to continue development many years into the future without having to rewrite again. It's so maintainable, like you wouldn't even believe. We didn't lose a valuable feature. We don't need to wait for a packet to send. And lneto would not be possible without its less glamorous cousin, the device driver. We got 3 networking drivers that work with lneto currently, and we support most of the bells and whistles. Not on all platforms, but 10 megabit internet, 100 megabit internet, you're good, and gigabit internet, soon to come. So, maybe you'd guess there's lots of lessons to be learned from building 3 networking stacks. I know I learned a couple at least. The lessons I will show you now, I wish to show you, if you so let me, are color-coded and shade-coded. So green to black diamond. The green circle is, hey, this will probably be useful for you, just any developer out there. And the black diamond is, hey, this is a very niche use case situation pattern. First up, who cares about heap allocations here? Show of hands? Okay. I was expecting much less hands. I'd be suspicious of these people right here, you say. Truth is, if you're using Go in the just normal Go, there's not much reason to care about heap allocations. The Go GC is amazing, as you might have learned in Jesus's earlier talk. And it's constantly evolving and improving. On the other hand, I'd say I'd need to care. lneto can process hundreds of packets a second on these microcontrollers with very limited memory. And the TinyGo GC is not the same as the Go GC, and it has some rough edges. So if I just allocate a single byte on every packet, eventually this program can crash and take down my user's entire computer, not just the program. So I need to care. Maybe I can rephrase this because making it heapless means removing all heap allocations. Let's rephrase so it's something we can all take home. I'd call it mechanical sympathy regarding heap allocations. So why have I listed this? Well, it just requires a little bit of training. I think that with knowing 20% of the places the Go GC allocates, you can eliminate 80% of heap allocations. And I think there's a good example I got here for you, de-risking your libraries. Right here, I don't know, you probably can't see this, but I've designed an interface for a decoder for a MQTT protocol. MQTT is like HTTP, so if you're not familiar with MQTT, think of HTTP. And the MQTT protocol has strings that are processed and then given to the user. And these strings are unbounded. They can be very large in size. And I purposefully designed some this decoder interface that heap allocates these strings to then give them to the user. And my implementation I provide in the library is memory limited. So it's not going to allocate an arbitrary sized string, an arbitrary number of strings. It'll fill its buffer up and then just error out. So this gives you peace of mind being a library developer. You don't have to worry about making your implementation super secure, performant in the face of gigabyte-sized MQTT messages. You can just provide the user with here's an interface. If you care about gigabyte-sized messages, implement the interface for your use case. I'm going to provide a constrained size, very simple implementation, and my library otherwise does no heap allocations. So you avoid CVEs, basically, by using this pattern. Work smart, not hard. Next up, avoid global mutable state outside of package main, but you didn't hear that. The Go standard library embraces global mutable state in several cases. Mathrand is probably the most famous you're aware of. Mathrand v2, they're kind of regretting that decision. just don't do it. The fix is that simple. Identify your data structures and add a method or kind of package that as an argument to your functions. Here's an example. The second most used library in the Go ecosystem, Google UUID, it uses like a global variable when you call new random, called the render. Just extract it. Make a generator type. The user can provide the random source with it. And you can add all the config you want to this generator. And it also like simplifies your outward-facing API. Now you don't have new random v4, new random v5, new random with hash. You can just like put that all into the configuration aspect. So to me, this feels like a no-brainer improvement. You're welcome, Google, if you're here. And for this one, let's jump straight into the example, composing structs with non-pointer types. All you need to know is that this is like a mamushka. This is code taken out of lneto. You have like the sense space, the control block, the handler, the con, the TCP pool. It's all like TCP data structures. And they're all like mamushka'd into each other. And tell me, does anyone see a pointer in there? Maybe I'm hiding one behind value. Well, the truth is, oh yeah, there's a slice in there. But no, you're too smart for your own good. Yes, there is a slice. Is there any other slice? Oh yeah, the remote adder. But data structures like structs, I mean, avoid a pointer if you can at all. This doesn't work when you have types that share internal data. Like TCP pool is something I actually create an instance as with a new constructor. When you can avoid using a new constructor, try using like reset or configure methods and declaring your struct with a var. The var keyword, name of your variable, type. I found this to simplify the API a lot. And you also avoid nil pointers, which is like something people throw a lot of doo-doo at Go for, because nil pointer dereferences are like a risk in Go. And also, I'm not sure if that second example is always valid. If someone's familiar with Go and can tell me if I can assure that if I'm locked when I enter reset, if that's valid. I'd be welcome. I think it's valid, but I might not just double check on that second example. All right, this one is a simple one. Build code around primitive interfaces. It's also very hard to sort of explain. There's a lot of hand waving. I feel it's sort of an art. All I can say is make your interfaces as simple as possible and no simpler. Sounds sort of pithy and meaningless, but I mean, I feel like unless you're really, really good, and I mean top gopher, you won't get your interfaces right this first time unless you're very familiar with the problem you're solving. I've recently started an image processing library, started developing it, and I'm sure I got the interface wrong. Absolutely. And I'll get it wrong a second time. And if you have suggestions, if you're familiar with image processing at a low level, I'd welcome suggestions on this interface I'm designing. Make the zero value useful. And this is a Rob Pike quote. This one you should be familiar with because it's one of the Go proverbs. Why am I mentioning it at FOSDEM'? So if it's something we all have heard before, we've all seen that 2017, 15-ish talk. Well, I feel it's not heated enough from my experience. And I think there's also like a little, I don't see it being used that often in enums as I use it. Here's examples of how I use it in the networking stack. The first case is state TCP closed. The RFC for TCP defines the TCP protocol defines that the closed state is an invalid state. It's pre-initialization. So it's a perfect case to have as a zero value for your enum of states. DHCP, on the other hand, does not have a state for the pre-initialization for when your DHCP client is like in an invalid state. So I use the empty identifier. I discard that namespace. Don't have a namespace for the DHCP state, and I recognize it as being an invalid state. Finally, when we configure Wi-Fi on this guy, which I just showed you, and just put the test, I defined the undefined join off enum value. And when the user does not set it in the config struct, I know that it's undefined, and I can make decisions based on other parameters in the config struct. So if the user set a password, I'm pretty sure they're going to be wanting WPA2 security if they have no password set. Pretty sure they're joining an open network like the ones we have here at FOSDEM'. Synchronous API, concurrent package main. Here's one I strongly suggest you follow. Just make your API synchronous and create Go routines in your package main. Just avoid these 3 keywords in your third-party package is my suggestion. Of course, there are use cases where maybe you're designing a machine learning library and you want to parallelize certain processes, and there's a very clear-cut use case for it, then go for it. But overall, if you're doing low-level stuff, I do low-level stuff in TinyGo, I always avoid these keywords in my third-party packages, and then use them in package main. And test-driven development. This might get some groans. TDD is like a contentious topic. Note the qualifier, well-known problems. Networking stacks, lexers, parsers, other well-studied topics are well-suited for TDD. When your input and output are known exactly down to the byte, TDD has been the most effective way for me to develop. Especially now we have these AI agents that can generate these tests automatically for you. So heads up from that one. Lastly, internal logging packages. This sounds like a specific pattern I feel could be generalized, but hey, I've used it for logging packages exclusively. So it consists of making the API the logger use for your project internal. Basically, hey, I do accept a slog logger from the user, which is like a standard library, but then I use an internal package for logging in my whole third-party package. And I'm going to skip ahead now. It lets you do stuff like, hey, I want to compile my project without the logging entirely. Easy to do that. And also add special logic to your logger, like printing all the heap allocations every time you see a diff in heap allocations. That's a use case I found tremendously useful. And this, my friends, is a story for another FOSDEM'. Well, what do you all think? I mean, it feels like a bit too simple to be systems programming. Maybe you're expecting a guide of how to implement lifetimes in Go. That'd be pretty sweet, but wouldn't solve most of my problems in lneto. Or maybe you'd be hoping that the final screen would be a prompt. The prompt I used to vibe code lneto. Claude is pretty good, but not quite there yet. And the answer is unsatisfyingly simple. Go is a systems programming language. You can write the drivers for the network interface, and then you can write a networking stack that uses the drivers to send the packets. And finally, the operating system, which handles the networking stacks. And if you follow these guidelines, I think you'll be better off. That's all. If this talk resonates with you, finally. And thank you to my cousin for letting me stay in her apartment this week.
Thank you for the free rent.
Mm-hmm.